Out of all 8,000 living species of marine invertebrates in the oceans, by far the largest, most deadly, and most intelligent are the cephalopods, a class of highly developed mollusks that includes octopuses, squid, cuttlefish, and the mysterious nautilus. Their graceful fluid movements, vibrant color changes, and complex brains make them one of the most peculiar and important groups of organisms in our oceans. Perhaps the most common type of locomotion used by cephalopods is jet propulsion. So cephalopods were our inspiration to create a jet-propelled cephalopod inspired car.
Inspiration from natural selection solutions adopted by nature and translate the principles to human engineering. Designs following biometrics will ultimately allow human productions to be more efficient, resilient, and sustainable. In this project, we are going to create a propulsion system inspired by a specific creature in nature.
First, the objective of this project is to construct a basic car inspired by cephalopod and engineer it for jet propulsion. Second, our aim is to find out how cephalopods move through the water using jet propulsion and to study their anatomy in a broad way. Third, we are also aiming to build a car inspired by cephalopods that is both fast and stable at the same time.
Our project is aimed at students who would like to understand more about cephalopods and their jet propulsion, and how we use this research to construct, model, and design a propulsion system for our car.
So our materials for the physical model include high-quality engineered wood to build the tracks for the car, two types of balloon depending on their elasticity, a small pump air, tiny bands, straws, hook, and four wheels. As for the 3D modeling software that we used to create a 3D model for the car, we used Onshape, and for the perspective drawings such as the isometric drawing and the orthographic projection, we used Triumph Cloud. Perhaps the most common type of locomotion used by cephalopods is jet propulsion. Jet propulsion is the propulsion of an object in one direction produced by ejecting a jet of fluid in the opposite direction. Now, many people believe that cephalopods move only by pushing through with their arms and tentacles, but they can actually move via jet propulsion, and only a very few amount of species can actually do that. Now, jet propulsion happens when the animal takes in water through its mantle. The water is then pushed through the siphon, which is a tube-like part that has a larger opening on the inside and becomes narrower. This is comparable to putting your thumb on the end of the hose and attempting to get the water to go more further. When wanting to move, the animal quickly and forcefully contracts the thick muscles of the mantle wall, squeezing water out of the narrow funnel with enough power to propel the animal in a burst of speed. And this whole process that happens is what inspired us to create a jet-propelled car, which actually moves via jet propulsion, and this is demonstrated by using a balloon and many other materials.
I used freehand sketching to draw or sketch a prototype of our project. I also used geometric tools and paper to sketch our cephalopod inspired car.
Isometric drawing, I used Trump Cloud to do it in isometric perspective. I did it in 30 degrees so it can be in 3D. For the orthographic perspective, we used also Trump Cloud. We used the three views. We used the front view, side view, and the plan view. So for the car, I brought the board, then I stuck the two sticks, then I put the water caps in the sticks. After I added the straw above the two sticks and the balloon was in the straw, so I propelled the car forward. To let the car move, I blow the straw, then the car starts moving.
So to design a 3D model of our project, I use the 3D modeling software Onshape to design and construct this model, and I feel like Onshape was really useful because it provides a various number of tools and services. So the first thing that I did was construct each part separately and then join it in the assembly. So I started with designing the car. So as you can see, I used many different tools such as chamfer, fillet, extrude, and many others. So I first designed this car, and I added windows and small details and the nozzle and some holes for to attach the wheels. And secondly, I did started with the wheels. So as you can see, I first started with the sketch. This was the initial sketch that I did. And after designing the sketch, I used the revolve tool to actually create the wheel. So as you can see, the initial sketch had this type of drawing, those type of zigzags, and when I did use the revolve tool, it actually made this shape of a wheel. And thirdly, I did the easiest part of the project, which was the balloon. I just drew a sketch of a circle and just used the revolve tool as the balloon. And the last part of the model was this part, which were the tracks for the car. And after I was done with designing all of the pieces and all of the parts of the car, I went to the car assembly and I just attached each of them. As you can see, I first added the car and then stick the balloon to it, and I duplicated the wheels for the car as wheels, and finally I just added the tracks. And this was the final result of our 3D model.
So one of the final processes of creating our project was building another prototype. So we learned a lot from the first prototype and just improved more in this prototype. As you can see, we added tracks which are built out of engineered wood, and the reason why we built tracks is to measure how far of a distance it will go. And as you can see, we created the car with straws, wood, and balloons and other recyclable materials. And one more thing you might notice is that the project actually has, or the tracks actually have different levels, different elevations. So as you can see, this one is the lowest one, this one is right in the middle, and this is the highest elevation. And the reason why we did different elevations was to test out how the elevations and how different heights will affect the speed, acceleration, and motion of this project or this car.